Hello, Mr. Claxton's algebra students. Welcome back. Hopefully you find these two images as funny as I did. Nothing like a little humor to get us started here. As we progress through this week, we are going to be working on some math. Hopefully you like getting back into that groove. Understand that extenuating circumstances may come up, things beyond our control. We will work through those as best we can. If there's something that, in your life where you need some support, you need some help, if it's with math, let me know. Email me, reach out to me if it's something else too. But we have two guidance counselors at the high school. I got their names up right now, as well as their email addresses. I understand that school may not be the most important thing in your life, and if that is the case, please reach out. Let's use those support resources best we can. Why are we here, right? Because learning is important. Maybe how we get out of the next mess that we find ourselves in. This is where we are for right now. So let's try to make the best of it. Let's get right into some equations. So what are we doing this week? We'll be solving radical equations and inequalities. You have solved polynomial equations in the past. Just a little reminder here, x to the 1/2 power is the same thing as the second root of x to the first power, or the square root of x. We do not include the 2 there just because we're mathematicians. We like to be efficient, right? So I am hoping that all of you will read the notes or the PDF that were posted. I'm just going to be highlighting here what the important parts are. It is an awesome problem. I'm not going to talk a long time about it, but the Michael Jordan problem is really cool. You can pause the video and try it on your own and read it. Really at the essence of what we're doing is we're going to be solving radical equations. Now, what are we going to be solving them with? Opposite operations. So the opposite of square rooting is squaring. The opposite of cube rooting is cubing. This is the recipe for that. The recipe for that is going to be isolate the radical. Let's get it by itself. After you isolate it, we want to raise each side of the equation to a power equal to the index. Now the index, like for a square root, that is the number 2. You'll see that here in a little bit. And then we're going to solve the resulting polynomial equation. And then we have to do the check step to make sure that our answers check out. Do not worry about extraneous solution right now. We'll talk about that later on in the week. So look at this first problem. We're going to solve a radical equation. We've got the square root of x plus 2. And then we're going to increase that by 4 and set that equal to 7. Well, we got to get the radical by itself. Subtract 4 from each side. After that, we are going to raise both sides to the second power. So we raise both sides to the second power. Why do we choose the second power? Well, really, because this is the second root. This is a square root. Remember how I said we just do not write the square there, but really there's a 2 there. That's why we raise it to the second power. Then the check step down here, you're going to want to do the check step every single time to make sure it checks out. So I'm going to go ahead and ask you to do that. You will make observations later on about what equations, what radical equations may have extraneous solutions and which ones may not. Looking at a guided practice example problem here, just notice that the x minus 2, that is the only thing, that is the only quantity underneath the radical, so that's the quantity we have to isolate. We do that by adding 1 to each side. After we add 1 to each side, we see here we have the second root of the quantity x minus 2, or the square root. And again, we do not have to have, whoa, what happened there? We do not have to have that 2 there, right? That 2 is not needed. we just assume that that is 2 if there's nothing there. We square each side. That undoes the act of square rooting. Some people like to put slashes through it, and that's kind of cool. That cancels it out. 6 squared is 36. Add 2 to each side, we get x equal to 38. Now we can do the check step for that. Take the square root of 38 minus 2, which is square root of 36. And 6 minus 1 is 5. 5 equals 5, so that does check out. If we were going to use a graphing technique to do that, we could go to Desmos. We could enter the left side and the right side in as equations. Both are y equals. So left side, right side, where do they come together? They will come together at 38, 5. So if you can't read that, that's x is 38, y is 5. So when x is 38, that would be the solution. Those two graphs, because they come together, we know there's a solution there. Looking at the next problem, I added this. This is not in the book, but I wanted you to see, okay, we have the quantity y minus 7 being raised to the 1/2 power. And then we're going to add 4 to that, set that equal to 9. Well, this is really like a square root problem, you'll see. But we're just going to isolate this, this quantity, maybe that we've never seen before, by subtracting 4 from each side. Once we see that we have a quantity raised to the fractional exponent here, that fractional exponent just means that 2 is going to be our index, and then that we're going to be raising y minus 7 to the 1st power. So really it's like saying the square root of y minus 7. So the square root of y minus 7 equals 5. We're going to go ahead and square each side, raise it to the 2nd power. Why is that? Because the index is 2. And again, some people like to go ahead and cross those out. If you want to, you can. So we get y minus 7 equals 25. Add 7 to each side, and you get 32. Do the check step. Do the check step. So after you do the check step, you see that this problem will check out. So we know that this is our solution. And all of your problems today in the problem set will have your solution. There will be no extraneous solutions. If you were going to check that by using Desmos, you could enter, once again, we would have to use x as a variable here. So notice that in the problem, it actually has y as a variable. Desmos requires you to use x. But where do they come together? They come together when x is 32. So x equals 32 is the solution. All right, well, I hope you enjoyed watching today. Happy mathing.